This question asks us about position, velocity, average speed, a few of these things. So we need to remember our relationship between position and velocity. And remember, velocity is the derivative of position with respect to time. So let's have a look at how this works. First of all, we're asked to find the initial velocity. So for part A, we need to take the derivative first of all. So if velocity equals the derivative of x with respect to time, then the derivative of this is going to be 2t minus 6. And when the question asks you for the initial velocity, then the initial velocity is when t equals 0. So I'm going to write that explicitly. And therefore, my initial velocity, v at time 0, equals 2 times 0 minus 6, which will be negative 6 meters per second. And that's the first question answered. The second part asks, when its velocity is 0, when and where does this occur? So let's have a look at that. When v equals 0, that means 0 equals my equation for velocity that I found here, which is 2t minus 6. Therefore, transposing, 6 equals 2t, and t equals 3. So the first part is velocity equals 0 after 3 seconds. The second part asks, where does this occur? So now I need to substitute my time of 3 into the equation for x. And here's my equation for x, so I'll substitute that in. And I have 3 squared minus 6 times 3 plus 8. And this all comes down to negative 1. So the velocity is 0 after 3 seconds, and the position when the velocity is 0 is at negative 1 meters. And remember, your sign is important, so that matters. So we're negative 1 meters from the origin. We would assume that that's 1 meter to the left of the origin. The third part of this question asks us for the average velocity, and this is where things can start getting a little bit tricky. Now, the average velocity is the change in the position over the change in time. So we'll write that down to be clear. This means that if the object turns around, the average velocity will not be the same as the average speed. So the average velocity for the first 5 seconds is the change in position over the change in time. Now we see that the change in time here is going to be 5 seconds. But if we're going to write an equation, let's write it completely. So now I need to find out the change in position. So at time 0, my position here is 0 squared plus 6 times 0 plus 8, which equals 8. At time 5, when I substitute my numbers in, I'm going to get 5 squared minus 6 times 5 plus 8. And that is 25 minus 30 plus 8 is positive 3. So therefore, the average velocity, the change in position here is 3 minus 8. And the change in time is 5 seconds. Therefore, the average velocity is negative 1, because this is negative 5 over 5. Notice how I've taken the final velocity and then the final position, and then the original position. We need to do it that way. So the change in a position is the final minus the original. So my average velocity for this is -1 meters per second. Now that's compared with the average speed. So for the average speed, I need to look at the total journey of this object and find out exactly how far it went. Now we know that the object turns around at some point in time. If I were to sketch this relationship, t squared minus 6t plus 8, I would see that there's a turning point. So let's have a look at what that looks like. So we started off with an object that had the position at +8. So we'll pop that in here, +8. This is where it started. We also know there was a time where it turned around. And when it turns around, the velocity equals 0. And we worked out earlier on in this that the velocity equals 0 when time equaled 3. And when time equaled 3, my displacement or my position was at x3, which is 3 squared minus 6 times 3 plus 8, which was at -1. So here. So what we can work out is that the object started at a position of 8 and it moved this way, and then here it turned around. And we note that after 5 seconds, the object was at position 3, which means it moved around and it finished here. So that means the total distance this object travelled is from 8 to -1 and back to 3. And we need to keep that in mind for this question. So my total distance equals from 8 to -1, which is 9, plus from -1 to 3, which is 4, which is 13 meters. My time is 5 seconds, and my average speed considers the distance over time and not just the change in position. So my average speed, let's write this down, equals the distance travelled over the time. And in this case, that equals 13 over 5 meters per second. Notice how speed doesn't have a direction to it, whereas velocity does. And that is always the case. So speed is just a modulus function. You can notice I've got those 2 lines there, whereas velocity has a direction attached to it. If you found this video helpful, please subscribe or like. Thanks.